All right, today's lesson is on 11.1. We're going to be starting to add and subtract polynomials. So in the first section, we need to discuss some vocabulary first, and then learn to add and subtract. So we've got this word polynomial. Basically, a polynomial is a monomial or the sum of two or more monomials. We look at these prefixes, mono meaning one, bi two, tri three. So this essentially means we're going to have one term, or two terms, or three terms. Okay, so a binomial is the sum of two monomials, a trinomial is the sum of three monomials. What is a monomial? Kind of a confusing definition, but it's a number, a variable, or the product of numbers and variables. Exponents have to be whole numbers, so that's really important. Okay, we'll talk about that. So examples of monomials can be a number, like it says, or a variable. Or it can be the product of numbers and variables. So I can have like 30, x squared, y to the fifth. As long as there's no addition or subtraction, we consider this one term and thus a monomial. What you can't have is negative exponents. I can't have a negative x squared, an x to the negative 2, which essentially also can be expressed as division, as we know from last chapter. So this would be an example of something that is not a polynomial or a monomial. We have to have positive exponents only. Okay, example of a binomial. Again, you're going to be just having the sum or difference of two monomials. So anything like 2x plus 3y, that's an example of two terms. A trinomial would be three terms, so something like x squared plus 3x minus 4. Okay. All right, so also one thing to keep in mind, poly we generally think of as many, so more than one. Students get confused. A monomial also is a type of polynomial. So when we're talking about polynomials, these are types of polynomials. It can be a monomial, a binomial, or a trinomial. If a polynomial has more than three terms, we typically just say a polynomial of four terms or five terms and so forth. It doesn't have a fancy name. All right, next we're going to talk about the degree of a monomial or a polynomial, which becomes important when you get to integrated 3. You'll be graphing polynomials. So you need to know the degree. And what that means is it's different in terms of a monomial versus a polynomial. If I just have one term, so let's say 2x squared. Let me add one more variable. Okay, so that's still a monomial, one term, and I've got 2x squared y. The definition of the degree of a monomial is the sum of the exponents of all the variables. Well, looking at my variables here, I have an exponent of 2 and an exponent of 1, so the degree would be 3. Okay. If I have something like negative 4xyz, what are the exponents on my variables? I've got an exponent of 1, 1, 1. So again, the degree would be 3. All right. Now, more importantly, we typically talk about the degree of a polynomial. It's the greatest degree of any term in the polynomial. So I'm going to take an easy one here. If I have x squared plus 2x minus 3. Okay, I've got a trinomial. And we have to look at the degree basically of each of the terms. The degree of this term would be 2. The degree of the middle term, we just have 1 as the exponent, so that's 1. The degree of a constant doesn't have an exponent, so it's a degree of 0. Okay, so you don't add these up. The degree of a polynomial is just the greatest degree. Okay, so we say this degree is going to be 2. It's the highest power of any of the monomials. Okay. So that can get confusing, the difference between them. So let me just kind of explicitly kind of show you the difference here. If I ask for the degree of a monomial, that's when we add all of these exponents. So I would take 4 plus 2 plus 3, which is 9. So the degree would be 9 of this monomial. okay? Now, a polynomial of 4 terms here, I'm just going to individually find the degree of each of those. I've got a degree of 4, degree of 7, degree of 1, degree of 2. I don't add those up to discuss the degree of the polynomial. Instead, I just take the greatest one, which is that 7. You're just looking at the biggest term, okay, the biggest exponent. So the degree here would be 7. Degree here, I add them, which is 9. Okay, so know that difference, okay? All right, so that's finding degrees, classifying by the number of terms. Now we get to talk about polynomials and special names of their polynomials, named by their degree. So if I have a 0 degree, what does that look like? It's just not going to have any exponents. So it can be any constant, 5 or 20, something like that. Because notice, what is here? Maybe a variable to the 0 power, as we know that that goes to 1. So that's a 0. A 0 degree polynomial is called a constant. Okay. Then if we have something that is to the 1st degree, what would that look like? Anything like 3x, I don't know, plus a number. Well, think of what that is. We know that that's linear if we were to graph that, if it was y equals. So that's why we call it a linear polynomial. Okay. Anything that has the highest power of a 2, so that is, we've seen those as well. I can have something like 2x squared plus x minus 5. We're going to be discussing these a lot in Module 12. These are quadratics. Okay, and remember what we're going to be looking at specifically later are these graphs are parabolas. Going to be dealing a lot with parabolas in Module 12. Okay, 3rd degree we call a cubic. So anything that the highest degree of any of the monomials would be a 3, so I could have something like 5x cubed minus 1. Okay. And a 4th degree is called a quartic, kind of like a quarter, quartic. So I can have x to the 4th minus 2x plus 1, anything where the highest term is a power of 4. And then we have a quintic. Whoopsie. Quintic for 5th degree. So anything, x to the 5th plus whatever. Okay, 6 or more, we just call it a 6th degree polynomial, a 7th degree polynomial, 8th degree, whatever. All right, so notice on this one right here, I would call this a binomial as well as a linear polynomial. So I could say it's a linear or a binomial linear polynomial and so forth. That's what we're going to do down here. Determine whether each expression is a polynomial. If it is a polynomial, find the degree. Determine whether it's a monomial, binomial, trinomial. Okay, so which of these are not polynomials? Remember, poly doesn't need to mean more than one. It just means the sum of monomials. This one fails because we have that negative exponent. So this is not. These are all polynomials. Okay. So we can classify B, C, and D by its degree. And the classification, I think I would be more specific. What they mean is a monomial, binomial, or trinomial. Okay. So we would call B by the degree would be a 3rd degree, or we call that a cubic. Okay. And of course it has 3 terms, so we're going to say that's a cubic trinomial. Trinomial. Okay. C has 1 term, so we know it's going to be a monomial. And what's the highest degree? It's that 1, so it's going to be linear. It's a 1st degree, otherwise called linear. We say a linear monomial. Okay, we also have a linear polynomial here, and it has 2 terms, so we're going to say it's a binomial. Okay. So on a test, I could ask you to, write an example of a cubic binomial. Okay, make sure you know those words and how to give an example. Okay. All right, next, on the back, we also need to know what standard form is. And this will be important when we go on to factoring in Module 12. So what is standard form? It just means when the terms are written in order, okay, from greatest degree to least degree. And we need to know what a leading coefficient is. Well, when the polynomial is written in standard form, the leading coefficient is basically just the coefficient of the first term. Okay, so let me show an example on the previous page. This one, for instance, is written in standard form because I have the terms written in order from the degree of each term. This degree is third, this guy degree is 1, this is 0. So they're basically descending in the degrees of x's, right? So this would be considered in standard form. So therefore, the first term, the leading coefficient, remember coefficient is the number in front of the variable. The leading coefficient would be 2. Okay, and like I said, this will be important in the next chapter, so we need to know these terms and what it means. Okay, so we're just practicing with this vocab. So example 2, it says write this polynomial in standard form and identify the leading coefficient. So we're just going to rearrange the terms. My first term would be this guy. Remember, it's going to be 2x cubed. Next term would be the one with the x squared. Make sure you take that subtraction sign with it. Then I have plus 4x and minus 12, okay? Now we've got it written in standard form. Identify the leading coefficient. Remember, it's just the number, not the whole term. So my leading coefficient would be 2. Okay. All right. So the next part, hopefully you've done things like this before, but we get to add and subtract polynomials. We can only add and subtract polynomials when we have like terms. Okay. Okay. So you basically have to have the same variables and the same exponents in order to add. Just like x's can be added to x's, x squareds can be added to x squareds. You can't add an x and a y, same thing. So when I say find each sum or difference, okay, we're taking this trinomial, we're adding another trinomial. We actually don't need these parentheses. The book will add them just so you can see, does it really matter? When it becomes important is if I have in B the subtraction sign, because as we remember, this actually means a -1 that will have to be distributed. Okay, but we can kind of ignore these parentheses. They're not giving us any operation like multiplication. It just says add these. Okay, so they want you to recognize, ooh, I can add the 12y and the y. I can combine the 20y squared with the -13y squared. And of course, numbers are like terms. I can combine those. And just be careful with your signs. So we're going to, try to write it in standard form because that's what it says. So I'm going to combine those y squareds first. Those will become 7y squared. And 12y plus y gives me 13y. And then the numbers, -2 and -10, will give me -12. Okay? So I've just combined all my like terms, written it in standard form. And if I ask for the leading coefficient, that would be 7 and so forth. So this is a quadratic trinomial, if I asked you to classify it. All right. Okay, the only difference on this one is, no pun intended, difference sign here. So we're going to put that -1 here and make sure we distribute that negative. Okay. Oh, and it looks like we can, well, we'll do that later. I'm going to drop these parentheses and distribute this negative. So I'm going to have -5h squared plus 2 minus 8h. And then go ahead and combine all of your like terms. So we have, notice this is a 1h minus 2h's, which gives me a -h, and we also have minus 8h, so we should have a -9h. Okay. Then I have my h squareds that can be combined, and that would be a negative 6h squared. Notice I'm not adding those exponents. I'm just combining those like terms. The exponents don't change. Okay. And it looks like all I have is one term that's constant, so I can just put plus 2. Now, I did forget to write this in standard form, so if you do that, just make sure you rearrange those terms properly. So I should write the negative 6h squared first, followed by the minus 9h, and then plus 2. All right. And that's it, knowing how to classify and name polynomials, write in standard form, and add and subtract.